Welcome back, class. Today we will discuss about the d pi p pi bonding. This is lecture number 2 of carbon family. So before going to start, I'll just discuss the question which I asked in the lecture number 1 of carbon family, that out of HCHO, CH4, C2, H6 and CCl2, which one will show the catenation property. So I hope most of you are able to answer this question. Answer is C2H6. Okay, why it is show? Because C2H6 can form carbon carbon single bond. Okay, so this is the reason that it will show the catenation property. Okay, so let's start the discussion of d pi p pi bonding. See, before going to discuss the d pi p pi bonding, you should understand about the valence bond theory, the whole concept of valence bond theory in detail. I'll just give a brief about this here, that how the sigma bond is formed. So sigma bond is formed by the axial overlapping. We all know axial overlapping, and this occur between S to S, S to P and P to P also. Okay, whereas for pi bond it formed by the sidewise overlapping, and it occurs between P to P, P to D and D to D. So the topic of today discussion is this p pi d pi bonding. Okay, and this is very important, you must remember for the whole lecture. This is how the bond formation occurs as per the BPT. Let's discuss some schematic representation, that how these bond actually form, and we will focus only on the pi bond formation, the sidewise overlapping. Okay, so this is the sigma bond, sorry, this is the pi, this is another p orbital. Okay, so this will now combine, and this will give this sidewise overlapping like this. Okay, so this is how this will combine. So this is what? This is p pi p pi. Then we'll take another example of p and d. So we have a p orbital here, then we have a d orbital. So the combination of this will give you, this is how this will combine like this. Okay, so here is the overlapping. So this is the example of p pi d pi, which is the topic of today's discussion. And one more, this video can be longer, okay, because I need to complete this topic in a single, so this video can be longer, but don't worry, it's very interesting one. The next one is, this is the example of p and d. This is the example of p and p, and the next one is the d to d overlapping. Okay, So for d to d orbital will form 1d orbital here, 1d orbital is here, then 1d orbital, another d orbital, and this will give you overlapping of okay. So this is the overlapping. So here the formation of d pi d pi. So this is what the schematic representation. Now we will solve some question, and on the basis of these question we will able to understand the concept. The concept is very important. Okay, so the first question is that how many p pi d pi bond in SO2, sulfur dioxide. Okay, so for sulfur dioxide we will first count the total valence electron. This is how the Lewis dot structure is formed. So for sulfur it is 6 electron in outermost valence cell, then 6 electron for oxygen. We have 2 oxygen, so total will be 18 electron. Okay, and if you draw the structure is look like this. This is sulfur, this is oxygen, and one bond is formed sigma, one is sigma here, and one is the pi bond. Okay, this is the pi bond, and one is the lone pair also. So now we'll count the bond pair electron. So the total bond pair electron here 1 2 3 and 4, so total bond pair is 8. Total bond pair electron is 8. Then lone pair electron, we will count the lone pair electron. So lone pair is 4 8 10, so total is 18. That means structure is correct, no doubt about this. Now the question is that which type of bonding. That means we all know that this is a sigma bond, one is sigma bond and one is the pi bond, but which type of pi bond it is, whether it is a p pi or a p pi d pi. Okay, so let's discuss this. See, if you go for the electronic configuration of sulfur, so sulfur total 16 electron is there, and this is the ground state. So 1s2, then 2s2, then 2p6, then 3s2, and then 3p4. So total we have 2 8 and 6, total 16 electrons there. Okay, so if you draw the 3s2 and 3p4, so we have a 2 electron in 3s2 and 4 electron in 3p4. This is the ground state, and you just look this structure. We have total 1 2 3 and 4 bond formation occurs, and as per the VBT theory we all know that only the unpaired electron can form bond. Unpaired electron, this is important one. Only the unpaired electron can bond form. So we have only two unpaired electron here in 2p 3p orbital. So how it is possible that it can form a 4 bond? This 1 2 3 and 4. And then we will talk about the excited state of sulfur. Okay, in excited state what will happen? The electron from, because we required 4 electron, okay, we required 4 unpaired electron, point to be noted. So what will happen here? This is the 3s, this is the 3p, and this is the 3d. So what will happen here? One electron from p orbital will jump into the d orbital. Okay, so now we have 4 unpaired electron, and these 4 unpaired electron now is capable to bond to form 4 bond, 1 2 3 and 4. So this is the excited state electronic configuration of sulfur. Now we'll take the oxygen one. We have 2 oxygen. So oxygen is in it's 8 electron. So 1s2, 2s2 and 2p4. So for the oxygen we will draw oxygen, electronic configuration of oxygen here. Okay, so 2s2, that means we have 2 electron of oxygen here, 1 2, and 4 electron in 2p4. So this is the 2s2 and this is the 2p4, correct? And so as for the other oxygen also, we have 2 oxygen na? One oxygen is for this and another one oxygen is for this. So oxygen, the second oxygen, 1s2, 2s2 and 2p4. Okay, so for then I think this color is not working actually, so we'll take this one. So we have 2s2 and 2p4. Sorry. So how the bonding occur? The question. See, as per the structure, we have one sigma bond here and one sigma bond here. That means we have total 2 sigma bond, and one pi bond is here and one pi bond is here. That means we have total 2 pi bond. Our question is that which type of, actually whether it is a p pi d pi, or you can also write that p pi p pi. Okay, so the question is that which type of pi bonding. Okay, so we'll draw the sulfur and oxygen. Now you just see that sigma bond can form, just come to this side. Yes, sigma bond can form by SS also, SP also and PP. We have unpaired electron in P and D in case of sulfur, and unpaired electron in P in case of oxygen. That means the formation of sigma bond only occur with PP. It cannot possible with SS or SP, because we have no unpaired electron in S. You can see here and you can see here also. So the first sigma bond can be formed very easily with this to this one, this one. Okay, this. So sigma bond is forming by the S of 3p, S of 3p, and 3p of sulfur and 2p of oxygen. This is the sigma bond. Okay. Now another sigma bond, because we have two sigma bond with another oxygen, so this will form by this p, this 2p. So I'm just writing by this. Okay, so another sigma bond is for 3p of sulfur to 2p of other oxygen. So this is the 2 sigma bond. Okay, now we'll talk about the pi bond. So pi bond, now just look at this one. Pi bond can also form with pp, pd and dd. Okay, so we have a p for 3p orbitals here, and p for 2p orbital here. So one pi bond will form by this, that means 3p of sulfur and 2p of oxygen, and another pi bond will form by this very important one, see, 3d to this. So 3d to 2p. So this is the pi bond. So the answer is we have 1 3p pi and 2p pi, and we have 1 3d pi and 2p pi. Got it? So this is structure of sulfur. Here this pi bond, okay, this pi bond is of 3p, sorry, 2p of oxygen and 3p of sulfur. Okay, this is, and this pi bond is 2p of oxygen and 3d of sulfur. Got it? So we have 1 pi and 1 p pi and 1 p pi d pi. So this is how you have to discuss the answer in examination. Okay, we will take one more example, then the concept is clear. So let's take the example of sulfur trioxide. Okay, I will discuss it, it is in a very quick session. So let's talk about the total valence electron of sulfur trioxide. 6 and 6 into 3, so total will be 24 electron. Structure, okay, and here is the lone pair, here is the lone pair, here is the lone pair. So bond pair electron 1 2 3 4 5 6, bond pair is 6, that means 12 electron, and lone pair 4 4 4, that means 12. So lone pair electron is 12, that means total is 24 electron, which is correct. Okay, now the question again, how many p pi and how many p pi d pi. Okay, so again the same thing, we'll go for the electronic configuration of sulfur. So sulfur 16, and we had already discussed it, that 3s2 and 3p4. Okay, so 3s2 have 2 electron and 3p4 has 4 electron. But here you can see that sulfur is capable to bind with the six bonding, 1 2 3 4 5 6, and here we have only two. So what we'll go for the excited state. Excited state, this is the ground state. Okay, the sulfur 16 excited state. So what will happen with the excited state? Excited state, that means sulfur, sorry, S, this is the 3s, this is the 3p, and we'll go for the 3d also. Okay, this is the 3d. So we required how many free unpaired electrons? 6, and we have only 2. So what will happen here? One electron from p will shift to d, and one here we have, okay, and one electron from s also will shift to d. So we have total 1 2 3 4 5 6 unpaired electron. Okay, so now this 6 unpaired electron is capable to bind with the 3 oxygen atom. So we all know that we have 3 uh, sigma bond and 3 pi bond. Okay, this is we had already discussed that we have 3 sigma bond and 3 pi bond. So we will discuss that which one is the p pi and which one is the p pi d pi. So let's talk about this. So S and O, 3 oxygen is there, 3 oxygen is there. So we will draw the electronic configuration of oxygen here also. So oxygen is then again it is, sorry, it is 2s2 and 2p4. So now 3 sigma bond, this is for one oxygen, you can go for the second one, you can go for the third one. So 3 sigma bond. Okay, I'll just give you this quick discussion here, no? One sigma bond can form by S to P, another from P to P, another from P to P. That means oxygen is only capable to give you 2p. Are you getting my point? So oxygen is only capable to give you 2p. Here you can see. So I can write here 2p, 2p. We have 3 oxygen, so we have total 6 2p. Whereas sulfur can give you S also, P also, and D also. So it will give you 3s, then 3p, then 3p, then 3p, then 3d, and then 3d. Okay, so this will give you 3 sigma bond, and this will give you 3 pi bond. Correct? 3 sigma bond, because we know that sigma bond can form with the sp, pp, and pi bond can form with the pp also and dp also. So the answer of this question is that in this case we have 1 p pi and 2 p pi d pi. So total is 3. So here you can write that here in this, you can write that, okay, this is a p pi, so this will be p pi d pi, and this will be p pi d pi. One is p pi p pi and 2 are the p pi and d pi. So this is how you'll answer the question. Okay, so I think this concept is very much clear, and before ending the topic, I have some questions to you. Find out the H2SO4, which type of bonding, p pi p pi p pi d pi, H3PO4. Okay, very simple. You can simply draw the structure of H2SO4. Okay, you can draw the structure of H3PO4 also, and with the help of these two structure we can easily find out that which type of. And one again, one thing you should remember that, see, oxygen, sulfur, nitrogen, phosphorus. Okay, so these oxygen and nitrogen they cannot extend their valency. That means they have limitation of 2p, whereas sulfur and phosphorus can extend their valency up to 3d. This can extend their valency to 3d orbital, which is not possible in case of oxygen and nitrogen. So this can extend their valency. So this is the question of sulfur and phosphorus. You can take hint with this. And thank you so much. You can answer your here on WhatsApp number also, 90393738. Or if you have any doubt, you can make a call to this number or WhatsApp. Thank you.